এই যে আমরা ডেডলকের চ্যাপ্টারটা শুরু করছিলাম, তাই না? আমার নোটের
জি স্যার, ডেডলক করানো হয়েছিল।
আমার নোটে একটা প্রবলেম নিয়ে আলোচনা করা হচ্ছিল। সো I was discussing about a problem, deadlock avoidance algorithm. Am I audible? Am I audible?
Yes, sir.
Okay, so is it clear for you? This my sharing page
Yes,
is
sir.
clear for you?
Yes, sir.
Should I make it bigger? Okay. So we can see here, this is a problem. So in assignment, I will give you a problem to solve. So you can see here the deadlock avoidance algorithm using Banker's algorithm. Actually, these bankers, this person, this scientist, he has many algorithms. He's a mathematician. He's a very renowned mathematician. He made different types of, he invented many important algorithms which is using in operating system, and very useful for operating system. This is one of them. This is called deadlock avoidance algorithm. That means before executing the processes, before executing a system, that means the collection of process need to execute in a system. Before executing, need to, can you hear me? আমাকে শুনতে পাচ্ছেন?
Sir.
হ্যালো,
জি স্যার, শোনা যাচ্ছে
জি
স্যার।
স্যার, শুনতে পাচ্ছি স্যার।
জি স্যার, আপনার কথা শোনা যাচ্ছে।
হ্যালো,
জি স্যার, শুনতে পাচ্ছি।
হ্যাঁ, হ্যালো, শুনতে পাচ্ছেন?
জি স্যার,
হ্যালো,
শুনতে পাচ্ছি।
যে হঠাৎ করে ওয়াইফাই নেটওয়ার্ক চলে গেছে। Anyway, I think I am audible. So can you see this share page? sharing pages?
Yes, sir.
Okay, is it here, right? Okay, visible, clearly visible, right? Okay, just now I was talking about the banker's algorithm. So this is the problem. Actually, this problem actually based on the selection of a system, or we can say the selection of the processes, and also need to check whether this process in this system, if you if you process one need to execute, that process is is that means if you want to execute, so all the process can execute sequentially or not. If execute sequentially, is there any deadlock or not, or safe or not? Okay, we need to check it. So this is very important. That means we need to avoid deadlock. Okay. So first of all, we need to calculate this problem, calculate the available matrix, then calculation, read matrix. Then the system is safe or not. If safe, then need to write the sequence, safe sequence. And if P1 request the source, then determine if the request is granted immediately or not. Okay. So in this situation, we can see that this table is given. So P1 until P5 is given. Last class I discussed. I'm just recalling you. Okay, recalling you. Here, maximum allocation means P1 maximum 7 instances from A can hold. Understand? P1 can hold maximum 7 instances from the resource A. P1 can hold maximum 5 resource instances from the resource B. P1 can hold maximum 3 instances from the resource C. Understand? So like this way, P2 maximum 3 instances can hold from A resource. So like this way, this is one table and this is allocation table. Okay. Allocation table is means actually how many the instances are holding from which resource. So in this case, for this 3 column is for allocation. Am I audible?
Yes, sir.
Yes, sir.
Okay, clear. Thank you. P1, there is you're not holding any resources from any instance from resource A. 0 means 1 means P1 holding 1 instance from process B. This 0 means P1 does not holding any instance from resource C. Clear? Can anyone tell me P2? This 2 means, what does it means? Anyone from this floor?
Sir, P2 is holding 2 instances from A.
2 instances from the resource A. Can anyone, another one? Anyone can tell me what about this
Yeah,
0 means?
P2 has no instance holding P2 no sorry,
Yes,
sorry.
try.
P2
No problem.
P2 is not holding any instance sorry, here from B
From
sir.
B,
Yes sir, from B sir.
B means
Sir B sir.
B resource.
B resource.
Okay.
Yes.
Yes. Anyone can tell me this one? Anyone randomly who wants to like to talk? Quick.
P3 is holding 3 instances from resource A.
Instances, 3 instances, plural. Again,
J.
3. Again, please.
Instances from
Yeah,
resource A.
good. Thank you. Anyone? Anyone? Quick.
P4 is holding on instance from B resource.
Good. Thank you. Okay. So now we clear. Okay. Which one is holding and which one is allocating? Okay. Anyway. So this resources is given. The A has maximum. A has total 10 resource in 10 instances. A resource has 10 instances. B resource has 5 instances. C resource has 7 instances. Okay. We can go straight to the solution. Calculation of available matrix. Available matrix, how to calculate the available matrix? We can see here. This is allocation table, right? This is allocation table. So A, how many holding by all the processes? 5, right? 7, 3, 2, 2, and 2. That means 5, 6, 7. That means 7 here. Huh? 7 instances is holded from A by instances are
All the
holded
processes.
by all the processes. It means that used processes are 7 instances. Sorry, used instances are 7. That means total is 10. That means 10 minus 7 is equal to 3. That means how many available? How many available? 3 instances
3.
available from A. For the B, we have 5 available total instances. For B, how many? We have 1 and 2. That means 2 instances already used by all the processes. That means 5 is total, then 2 already used. How many available? 3.
3.
For the C, 7. 7 minus 5 by 5 is 2 plus 2 plus 1. That means 5 instances used from the by the all the processes. It means that we have the available matrix. A is 3, B is 3, and C is 2. This is the available matrix. Okay. Okay, this is so this is the so if we have available matrix, can we calculate total resources? Is it possible?
Yes, sir.
Possible, right? So we have to add the allocation plus available, we can get the total resource. Clear? Okay. Second question is need matrix. We need to calculate the need matrix. Calculation of need matrix. How to do that? Very easy. This is maximum allocation. So for example, if it is nothing written in the top, for example, mistakenly written on the top. So how can you identify which one is the max allocation, which one is the allocation table? Can you recognize?
Yes, sir. Max allocation will be max allocation values will be bigger than the allocations value.
Correct. Okay. So max allocation table must bigger than allocation. Correct. If both table are same, then very difficult to identify. Right? But if, for example, this table and this table is given, all are same. This table have only one instance is bigger than this table. Only one. That means we can understand that this is the max allocation table. And this is the allocation table. Understand? For example, if this table and this table same, but here is 3, here is 2. It means that this one is the max allocation table. Okay, so what is the definition of need matrix? Need matrix, how can we calculate? Max allocation minus allocation. That means 7 minus 0 is 7. B1. 5 minus 1. That means allocation maximum can allocate P1 is 5. B can allocate 5 instances, but allocated only 1. That means need another 4. 5 minus 1, that means 4. Same wise, P1, C can max allocate 3 instances, but There is no allocation. That means 3 minus 0 means 3. Should I explain some more? 3 minus 2 is
No, sir.
1. Say 1. 2 minus 0 is 0 is 2. 2 minus 0 is 2. So like this way, 9 minus 3 is 6. 0 minus 0 is 0. 2 minus 2 is 0. 6, 0, 0. Likewise, 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 1 is 1. 4 minus 0 is 4. 3 minus 0 is 3. 3 minus 2 is 1. See, finish the matrix. So, before going for the next steps, we must know the available matrix and we must know the need matrix to find out the safe state. So number 3 now is the system, that means this table is safe or not. The system is safe or not. How can we calculate? This is a question, right? If this information is given, we can now find safe states. How do we find? Very easy, very easy, very easy. There is one equation. Just remember one equation only. For each process, if need I is less than or equal to available, if need I is less than or equal to available, then available equal to available plus allocation I. Allocation I. You can see the base I. Need I, allocation I. Understand? So we go for the need. P1 need is 473 and available less than or equal to. Need I is less than or equal to available. We have to check. Need 743. You can go to the need matrix. 7, 4, 3 for P1, right? A is 7, B is 4, C is 3. Okay, available A is 3, B is 3, C is 2. 3, 3, 2. So we need to check here. 743 is need less than or equal to 332. So we will check A, B, C, C. 3 is less than or equal to 7. Is it true? Is it true?
No, sir.
No, that means false. We will check on the 1. If 1 is false, then no need to take that process to continue. That means false means we stop here. Okay. For P2, because we have P1, P2, P3, P4, P5. For P2. For P2, what is the need value? 1, 2, 2. How can we get it from here? 1, 2, 2. 1, 2, 2 is less than or equal to 3, 3, 2. What is 3, 3, 2? Is available. So we need to compare. Is it 1 is less than 3? Yes. Is it 2 is less than 3? Yes. Is it 2 is less than or equal to 2? Yes, because equal. That means this is true. If this is true, it means that we need to update the available value. We need to update the available value. How can we update? Available plus allocation I. That means we have available is 332 plus allocation of P2. Let's go to table. What is the allocation of P2? Allocation of P2 is 2, 0, 0. Am I audible? Am I audible? Okay.
Yes, sir.
Say 2, 0, 0. Understand? 3 plus 3, 3, 3, 3, 3, 2 plus 2, 0, 0. We need to add the allocation of P2. So how 3 plus 2 is 5, 3 plus 0 is 3, 2 plus 0 is 2. So this is the updated value of available, correct? Next we go for P3. P3 the available need from the need matrix we can get The need value for P3 is 600. You can check it here. Now 600. Okay. So is this 600 is less than or equal to this is updated available, right? We need to take this updated available. 3, 5, 3, 2. Now we check. 5 is less, 6 is less than or equal to 5. Is it true? 6 is less than or equal to 5. Is it true?
False.
False.
Sir,
That
false,
means
sir.
that means we need to go to the next process.
It will be
P4.
totally
For
false.
P4. Yes. For P4, we can see that this is totally false, right? No, not totally false. That means 5, 6 is less than, not less than 5, right? Or equal. One is false, that
Yes,
means false. Other three, it is correct. 2 is 0 is less than 2 is also correct. But we said that if one is false, that means all are false. Like this way, 4 for process 4, we can see 0, 1, 1 is need from the need. Can you remember? For P4, 0, 1, 1. And for P5 is 4, 3, 1. We are not coming here. Huh? We will see here. For P4, 0, 1, 1 is less than or equal to this updated available 5, 3, 2. That means we need to update the available. This is true, right? 0 is less than or equal to 5 is true. 1 is less than or equal to 3 is true. 1 is less than or equal to 2 is true. Correct? So all are true because of that. Available is equal to available plus allocation of P4. What is the allocation of P4? P4 allocation is 2, 1, 1. P4 is allocation is 2, 1, 1. It means that 5, 3, 2 plus 2, 1, 1 means 5 plus 2 is 7. 3 plus 1 is 4. 2 plus 1 is 3. Correct? So like this way, P5. We get it? Is this true? So the available is 7, 4, 3. This is available plus the allocation of P5 is 0, 0, 2. We can get it from allocation table. So here you can get total is 7, 4, 3 plus 2 is 5. Correct? Okay. So previously we have seen that P1 and P3 was false. Correct? This is one thing you need to remember. You must remember. Huh? Because we already checked P1, P2, P3, P4, P5, right? But P1 and P3, we got this false. So in this case, once we complete until 5, then we will repeat. We will repeat all the falses one. If it's still false, it means that there is not safe. All the processes are not safe. But if we check that, okay, P1 will become 743 was the need of P1, but our available is 745, 745. We can see 7 is equal to 7, 4 is equal to 4, 3 is less than 5. That means all are true. That means true. And available plus the allocation of P1 is 755. Clear? Then we go to the P3 because it was false, right? We got false is P1 and P3. P1 and P3 false. So we need to check again. P3 need was CP3 into 600, but this one is the updated one, 755. We got it from here, from P1, updated from P1 available. Here we can see if this is true, that means 6 is less than 7, yes. 0 is less than 5, yes. 0 is less than 5, yes. Then available is 755 plus the allocation of P3. So interesting thing is once you get complete all the process become true, can you remember what is the value of this 10, 5, 7? Have you seen this sequences?
Yes, sir. total allocation.
So 7 plus
Sir,
10
total
percent.
resources, sir.
Exactly. That means once it use any process use the resources once complete to access all the resources, all the instances, then release, right? Once execute, then release. It means that until P1, P2, P3, P4, P5, all the processes used first, then release all the resources, instances, correct? So in this case, we can say yes, this system is safe because all got true, right? Okay, safe. There is no deadlock. There is no deadlock. Yes, this system is safe and there is no deadlock. Then the question said that what is the safe sequence? Safe sequence is we got true first, P2, then P4, then P5, then P1, then P3, right? We got the true statements sequentially like that. P2, P4, P5, P1, P3. Like this way, we can easily get the sequences. Do you have any question on that?
No, sir.
Because okay, good. The same thing we will use for the next problem. So this number 4 problem is if P1 request A is one instance, there is no need B, C, if it's one to allocate 2 instances. That means P1 already have 0, 1, 0. So it needs 1 resources for A, that means 1. There is no resource instance from B, no need. But the 2 resources from C, that means supposed to 2, 0, 1, 2. Sorry, 1, 1, 2, like this way. It's 1 to use. So in this case, if P1 request, should this system, if the system take it, can take it immediately or not? That means this request, the system can take or not. We need to check. Because if take it, after we just check now that this one is already safe state. Suddenly P1 requests some instances. Is it with the system if give the P1 that amount of resources, can we make the system still in safe? If safe, then we can take it immediately. If not safe, that means we cannot take immediately anymore. Because if we take P1, that request, the system become deadlock. That's it. So in this case, okay, we have also very interesting some steps. Some student, what they do, they just copy paste these steps. That means they put it in their hand, in one, cheat code. That means cheat paper. Okay. So better you practice yourself in your home. Just remember these 4 steps. Finish. Okay. Don't try to copy in the paper. Try to copy in the brain. How can you do that? You have to practice. Okay, if a new request arrive, okay, that means P1 request, right? What happened? What we need to do? Is it visible? Is it visible for everyone?
Yes, sir, visible.
Okay.
Yes, sir.
Okay. If a new request arrives, or step 1, you need to follow this step 4s. 1, 2, 3, 4. Okay. Step 1 is if request I, that means I means P1, P2, P3, 1, 2, 3, like that, right? Is P request I is less than or equal to need I, then go to step 2. Then we go to step 2. If request I is less than or equal to, so first we need to compare with the need I, then available. Our available is 332, right? And the need of P1, we will see how much from the need table, need matrix table, we can find is the need for P1 and available is 332 is given in the question. So if this is true, then go to step 3. What happened? We need to update the available, like available minus request. we need to update the need minus request I, need I minus request I. Then we need to update allocation. Three things we need to update: available, need, and allocation. Three need to update. But you have to remember all requests, because sometimes these ones mix up this one, mix up this one. So first you need to remember need, then available. Need, then available. Okay. So you can set it here also. First we bring it to need, then available, then allocation at the last. Here is compare with the need, compare with the available. We can make it need equal to need I minus request, available equal to available minus request. Then you can say allocation, you need to plus allocation I plus request. So like this way you can remember these three steps. Four steps just now we have find if need is less than or equal to allocation, that one. Use algorithm, Banker's algorithm to check the process sequence are is safe or not. If safe, then we will grant immediately. If not safe, then we will not take it immediately. Okay. Step one, P1. The question was P1 request 101, 102, right? 102. So we need to do solution for P1 request, right? 102 is request is less than or equal to what is the need of P1? 743. 743. Okay. 743. Is it true or false? Request less than or equal to 743. That means this is need. 7. 1 is less than 7. 0 is less than 4. 2 is less than 3. It's true. Then go to step 2. First is need, right? Second one is available. That 1 is less than 3. 0 is less than 3. 2 is equal to 2. That means equal. We also have equal. This is also true. Then go to step 3. Available equal to, first if you start need I is equal to need minus allocation. Sorry, request. Request is 102, right? Need is 743. Minus allocation is 102. So it becomes 7 minus 1 is 6. 4 minus 0 is 4. 3 minus 2 is 1. 6, 4, 1. This is need. Need I. That means need P1. Available, how can we calculate? Available minus request. That means 3 minus 1 is 2. 3 minus 0 is 3. 2 minus 2 is 0. 2, 3, 0 is the available, and this one is need. Allocation is request plus allocation of P1. This is the allocation of P1. I, there is I, right? Allocation of P1. That means 0, 1, 0. That means 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 2 is 2. So step 1 is step 2, step 3. We already prepared. Now we go for step 4. Very easy. Step 4 is Banker's algorithm. Just previously we use here. If need is less than or equal to available, then available equal to available plus allocation. Same allocation I. For P1, we can see this is the need 641. Where you can get it? This is the need 641. New need, right? Not the old one. After getting the request, we need to see the need. Okay. Less than or equal to this 230 means the new available. New available 230. Okay. So new need, because this is P1. If it's supposed to be P3, then we will go straight as before. Then we need to change it. We need to compare the elements for P3. Okay, if P3 is request, okay. But here is P1 request. So we change all the things for P1, then get the new available. We check if 6 is less than 2. No, false. Then we go for P4. P4 is 1, 2, 2 is given in the table 1, 2, 2. Only change P1 because P1 request. Others will be the same. For P2 1, 2, 2 less than or equal to 230 because this is newly available. For P3 600 is less than or equal to 230 also false. For P4 0, 1, 1, 230 also false. Why? 0 is less than 2. Correct. 1 is less than 3 is correct. 1 is less than 0. Is it correct?
No, sir.
No, then it is false. So all are false. That means answer is, you have to write the answer. P1 102 is not granted immediately. Finish. Okay. If like I think I give one assignment before last year or last semester. Okay. That means it goes from 1 until 5, then P1, P2, P3, P5, P4. Then again it needs to compare. It can be 2, 3 times. Because if you have P5, right? If you check P1 false, for example, you may get P3 is true. If get true, then you need to check again P1. Some student can answer question that, sir, how many times will you do? Right? How many times we will continue like P1, P3 because P1, P3 got false, right? Previously, P1, P3. So how many times if you have another 5 processes false, how much we will die? Do we need to try until infinite time? No. If there is first time, if there is update, you do the second time. If you get some update, you do the third time. If you get update on available, you can do the fourth time. If you don't get any available and any update, so stop. You say there is false, it means that the system is deadlocked. Understand?
Yes, sir. Available blocks need to be updated.
Exactly. Available value must be updated if you want to continue. If no update, that means stop. Here you can see there's no update, right? So I did not continue because all false. No chance. No chance to update the available. So one time, don't worry about any question. Once I give a question like that, the first step, in step 1, it becomes false. Okay. Step 2 also false. No, that means step 1 false, that means cannot go step 2, right? So this is 4 marks. I gave 4 marks in step 1 is false. 4 marks. That means need to write only 1 line. Student is stuck. They spend 10 to 15 minutes. Is it false from me or not? That means false from the student or not? Check again, check again, check again. And want to watch the equation from others. Is it my equation is correct or not? Because this one was my technique. Then I set the problem. Step 1, it become false. That means cannot go other steps. Then student need to write immediate straightly this sentence that P1 auto is not granted immediately. Once you get here, false. Okay. Correct. Do you have any question? If no question, I can end this class today. Any question?
No, sir.
No question.
Okay, then we have another 2 classes, right? I think we can complete another. Oh, okay. Now your job. Can you see this slide?
Yes, sir.
Okay, this
Yes,
is
sir.
slide. Now I think you can understand everything. You can see avoidance, detection, recovery from deadlock. Slide is actually, you can see whatever I explained. Mutual exclusion, whole and wide, no preemption, circular way. Already explained during the class. The slide is just explained with short from a short description, but my note you can see is explainable. I explain each part. Okay. Resource allocation graph already discussed, right? I also give some problem. You can solve this problem also. Is there any deadlock or not? Is there any deadlock? Is there any deadlock or not? Okay. Is there any deadlock? See, no deadlock. So like this graph you can see in the exam and need to find is there any deadlock or not. I think if you read now this slide, then you can understand what I discussed. Okay. How can we prevent visual exclusion and hold and wait? Okay. Through this, we can prevent no preemption, circular wave. We can prevent the deadlock. This small code for circular weight implementation and deadlock avoidance. Of course, this is safe state and unsafe state. Yeah, safe state, unsafe state, and deadlock state. Deadlock is once deadlock. Once unsafe means deadlock. There may have deadlock. Okay, resource allocation graph is still the different way they are explaining. This is Belka's algorithm already discussed just now. See available max allocation needs. This is the matrix definition you can find here. Okay. Even if resource request is given, see you can see these equations. If this is we check request is less than or equal to need I, request I is less than or equal to available. Everything is given. Yeah, this is one example. They use Banker's algorithm. How can we avoid? This is the same problem, I think. 10, 5, 7. Yes, same problem. 3, 3, 2. Same problem. Okay. This is need matrix. This is very easy. This is once the 102 is requested by P1. P1 request. Here they say P0. P0 request is granted immediately or not. Here they see P4 and P0. P4 and P0. So you need to check first P4, then you need to check P0. Okay, maybe I will give the assignment from here. Okay. I think that's all. This is resource allocation graph. We can say this one. There is circular weight or not. Okay. I think that's all. There is detection algorithm. I think it's almost similar to the from the avoidance algorithm. We can easily identify the detection algorithm. Okay, this is one example. If there is any deadlock or not. Okay, this 7 instance, 2 instance, and 6 instance. We can detect easily. So I think how can we terminate the deadlock? Okay, so of course that is the last way to terminate the deadlock is to delay the process. Okay, these are the discussion from this chapter. Hopefully all of you need to see the examples in this slide also. Okay, if this slide is not shared with you, please let me know. I think already shared. Thank you very much. If you have any question, please.